Bright Tuty. Every student matters.
We'll be talking about nuclear energy. Now, what is nuclear energy? The energy which is obtained through the or from the nucleus of an atom. That is known as nuclear energy. Now, this nuclear energy can be obtained by two ways. The first way is we take a heavy nucleus. By heavy nucleus, we mean that the nucleus of such an atom or element which has a greater atomic mass. We know that atomic mass is equal to the number of protons plus neutrons, and both these subatomic particles, the protons and the neutrons, are present in the nucleus. So, if the number of protons and neutrons are more, then the nucleus will be quite heavy. Fine. So, if we take a heavy nucleus and we strike it and cause some disturbance in order to disbalance, in order to disturb the balance of attraction of these particles, then this nucleus breaks up. And when this nucleus breaks up, it splits up into smaller nuclei, which is the plural of nucleus, and along with this, tremendous amount of energy is liberated. This is nuclear energy. And this phenomena, this process in which we are breaking up or splitting up a bigger nucleus, a heavy nucleus, into smaller nuclei is known as nuclear fission process. Fission means to split up, to break up. So, this process is known as nuclear fission process, because here we are splitting up or breaking up the nucleus of a heavy element, right, having greater mass number. Now, there are various elements which are used for this particular process. Example, you need to remember, one is uranium, or we can take polonium, or we can take plutonium, and many more. You need to remember 2 or 3 examples. These are all heavy nucleus. They are all the elements which have very great, very big atomic mass, very big nucleus. Fine. So, this is one way by which we can utilize the nuclear energy. There is yet another way. Now, that way is when we add up the smaller nuclei. Smaller nuclei means those nuclei which have very less atomic mass, right. When we add up these smaller nuclei, they combine to form a bigger nucleus, and in this process also a lot of energy is liberated. Now, in this particular process, we have combined or joined up or fused two smaller nuclei. That is why this process is termed as nuclear fusion process. Fusion is joining together, combining together to add up, fusing, right. So, this is nuclear fusion process, right. Just for our detailed information, we need to know a few things based on this nuclear fission and nuclear fusion. First of all, let us talk about a bit about nuclear fission. We have said that this nuclear fission is the process in which a heavy nucleus is broken down into simple smaller nuclei along with release of lot of energy. And when I am saying lot of energy, I am probably underestimating it. I think you will be able to get a better idea if I tell you that if I take one atom of uranium and I take the fission process, right, I do the fission process of this uranium, this is equivalent to the amount of energy produced by combustion of 10 million atoms of carbon. 10 million times energy. I think now it is generating a bit of interest in this, that nuclear energy It is really a great amount of energy getting produced in it. Fine. So, this is a tremendous source of energy, and this energy we utilize in two ways. One is a peaceful use. In peaceful use, we are utilizing it in the form of nuclear power plants. Now, these are the power plants, that means these are the places where electric power is generated with the help of nuclear energy. We take uranium or any substance as a particular fuel. We do the fission process, out of which a lot of energy, tremendous amount of energy is liberated. This energy is utilized in order to generate electrical energy, of course, by running the turbines. Fine. There have been many nuclear reactors in India. You need to know a few names like Tarapur, Kota, Narora atomic power plant in UP, Kalpakkam, Tamil Nadu, we have a power plant, so many. So, we are already having many nuclear power plants already running and functioning, and they are contributing by generating electrical energy for us. Fine. Second is the destructive use of this process that we have already done. We have heard about the atom bombs, those which were dropped on Hiroshima and Nagasaki in the World War, Second World War, Japanese cities, and so much of destruction was caused because the amount of energy produced was huge. Those atom bombs were based on nuclear fission process. Fine. So, that is quite destructive. Fine. Now, nuclear fission energy, if we do this process in order to carry out the process and take energy, this is quite advantageous because of many reasons. One reason is, first of all, the energy liberated is huge. Second thing, if we just place uranium as a fuel in the nuclear power plant, we can continue running with some chain reactions you will be studying in higher classes. It continues of its own. Fine. So, a lot of energy, lot longer time that is generated or produced on its own, it is a continuous process. Got it? But there are certain limitations which are very important. You need to remember the drawbacks or limitations of using nuclear energy. Very important. The drawbacks or limitations because of which we are restricted to use it. Number one, the uranium which is used in the nuclear reactor as a fuel, or by way of that any other particular substance which we are using, that is very expensive also, and they are quite in limited amount in our earth crust. Second drawback is, which is very concerning, when this process takes place, a bigger nucleus is broken down into smaller nuclei. Along with energy, there are certain harmful radioactive waves also get emitted. Now, these alpha, beta or gamma rays which emit as a byproduct of this particular process, they are very harmful for humans, and that is the main problem. First is this waste that is generated, where and how to dispose it, how to get rid of this waste, that is a major threat. Plus, if these waves or radioactive waste they leak out, there is a threat of leakage. There are already been 2 instances in human history where nuclear reactors have a leakage, and this has led to very disastrous effects. One was in 3 Mile Island in America, and second one was Chernobyl in Soviet Union, USSR, Russia. So, all those areas where the leakage occur, they have disastrous effects, causing a lot of damage to life, and that is why there is a threat to it. So, these are the various limitations, these are the various reasons because of which this nuclear energy, that is also a bit of threat, or we need to be very cautious while using it. Then we talked about nuclear fusion, a bit of detail of fusion. This nuclear fusion reaction, in this reaction We just said that we fuse two smaller nuclei, like I take an example of hydrogen. These two hydrogen nuclei are joined together to form one helium atom. This process is taking place in sun and in all the stars, and the amount of energy liberated we are already aware. In sun, the secret, the source of sun's energy is the nuclear fusion process taking place. Fine. Now this nuclear fusion is very much advantageous as compared to nuclear fission, because number one, the hydrogen which is required for this process, this is in plenty. Fine, in plenty. Second thing, the amount of energy produced in fusion is much more as compared to fission, right? And third and the most important thing is, there are no harmful extra products formed during this reaction. So if this fusion process is taken out, it is going to solve probably all the energy requirements and all the energy thoughts, concerns going on. But the problem is, it's not so simple to make these hydrogen atoms undergo fusion, because this process requires millions of degrees of temperature and millions of pascals of pressure, and this is the major drawback, that till now we have not been able to control this particular fusion process in a peaceful way. We have not yet been able to generate fusion energy. The disastrous effect, the worst point is, we have already been able to use this fusion in a destructive manner in the form of hydrogen bombs. Now these hydrogen bombs, they are considered to be far destructive as compared to the atom bombs, because the idea behind this is, first of all, we will do the nuclear fission of uranium or any other radioactive material in the core, because of which so much temperature will be produced, which will cause the surrounding hydrogen to get converted into helium, and thus causing fusion reaction. So in this case, the amount of energy will be 100 times more, causing 100 times more destruction than what was caused by the atom bombs, right? So this is hydrogen bomb, the destructive concept of nuclear fusion reaction, right? So this is all about fission and fusion. Now at times you are given a question in the examination, you will be asked that there are few elements A, B, C and D, and you will be given the atomic masses of these elements. You will be asked that A is, for example, the atomic mass is 2, the atomic mass of B is 80, the atomic mass of C is 96 and D is 238. Which among these will be best suitable for nuclear fission reaction? So when we talked about nuclear fission reaction, we just said that we will be requiring a heavy nucleus for it. So the element having the maximum atomic mass will be best suitable for nuclear fission, for splitting up, and that is D. And for fusion reaction, we will be requiring that element having very less atomic mass. So among these, A will be best suitable for nuclear fusion reaction. These are 1 marker questions, they are just directly asked over there so many times. Fine. Next that will be asked about in the examination is, we will be given 3 elements A, B, C, or 3 fuels. We will be said that the calorific value, I hope you remember what calorific value is. Calorific value is basically the amount of energy produced by burning unit mass of a fuel. Fine. The calorific value of this fuel A is, let it be 30 kilojoules per gram. B is 80 kilojoules per gram. C is 150 kilojoules per gram. which among them is the best fuel. So, just given this information, if we are provided, we will say that the fuel having the maximum calorific value will be the best fuel. But if some added information is given to us, like we are being told that upon combustion the byproducts of A are carbon dioxide and water, B are carbon dioxide and water, C are carbon monoxide and sulfur dioxide. Now our perspective will change. How? Now C, although it was having the best calorific value, it was providing the maximum possible amount of energy, but since it is producing poisonous gases, that is why we will not use it as a fuel. Why? Because this is very harmful for the environment, for us. So, we will forego, we will just compromise with the amount of energy that it was giving. We need to see the long term effects it will be having. Fine. So, now B will be our choice. We will say that among these three, B is a good fuel to be used. Fine. So, this is the criteria you need to see. You do not have to see only the amount of energy liberated or only the calorific value of fuel. You also need to say what are the byproducts. If it is producing any harmful gas, if it is producing any poisonous gas, if it is causing a threat or posing a danger to the environment or to the survival of organisms, we will prefer to avoid that particular fuel. Fine. So, this is all about the sources of energy that we have studied. Hope you have understood it. Thanks for watching.